Hi everyone, welcome to today's webinar, Engineers Behaving Badly. My name is Eva Dace and I'm a member of the marketing department here at Vitech, and I will be your host during today's webinar, which is being presented by Zane Scott. Zane is the Vice President of Professional Services here at Vitech, where he is the head of consulting services. For more than 6 years before joining Vitech, he worked on DoD contracts, analyzing and improving processes, and applying best practice models using MBSE and CORE to provide the modeling support. He has taught in a variety of disciplines in college and professional classes. He is a trained hostage negotiator and interventional mediator and speaks often on communication and conflict management. Now, before I let him take the stage, I need to review a few housekeeping matters. Please take a few moments to get comfortable with your webinar control panel, as this is how you will submit your questions and comments. We will address the questions at the end of the presentation, so please stay tuned. Next, I'd like to answer our most asked question. The webinar is being recorded today. You will find the recording in the webinar archive in the resources section of our website within 24 hours of the live presentation. Today's webinar is brought to you by Vitech's newly redesigned MBSE Fundamentals course. To learn more about how to bring premier engineering techniques to your team, please click on the link you see in your chat panel right about now. Okay, so now let me hand it over to our presenter. Welcome, Zane. Thank you so much for joining us today.
Good afternoon, and thanks, Eva. I'm happy to be here, and I appreciate everybody who has taken an hour out of their busy day to be with us. First thing I want to do is go over what we're gonna cover. No matter what you might have concluded based on our title, we are going to be talking about the logical architecture, the behavior of the system. Some folks talk about it as a functional architecture. Behavior and functionality get run together in our parlance, but basically we're talking about the behavior of the system and the system's parts and subdivisions. As the basis of our discussion, we're going to look at Johannes Gutenberg, SE. I don't think that he had a certification system around, so I was tempted to call him a CSEP or at least an ASEP, but he didn't live in a time period when he could get certified, although he certainly could because of the way that he constructed his innovation here, which of course is the Gutenberg press, or the printing press. We're going to talk about some of the innovations that he came to with that invention and talk about how he was able to do that. Unsurprisingly, of course, I think the answer to that is that he was able to do it based upon an understanding of the logical architecture, even though he probably would not have called it that. Then we're going to talk about some pitfalls and some things that we see, some misbehaviors, if you will, that we run into in our own engineering efforts and how to avoid those, and talk about how Gutenberg avoided most of those and what advantages that offered to him, and then we will conclude from there. So let's get started. First off, what we are talking about, of course, is the logical architecture, the system behavior. What is it exactly that the system does? We need to always keep in mind that it's what the system does that satisfies the needs of the customer. It's what the system does that allows it to develop the synergy that's talked about in the definition of a system. You know, whether you're looking at the NCOSE definition or other definitions of a system, it always carries the elements of having more than one part, and the combination of the behaviors of the different parts enables it to perform behaviors and perform in ways that the parts could not perform themselves. So it's this logical architecture that allows the system to develop that synergy that is so valuable. And this is the key concept here for us, that it's really the behavior that satisfies the needs. It's the physical architecture is the way to that behavior. It's the way that that behavior is allocated into the physical world and performed, but it is the behavior itself that leads us to the success. Too often that's given short shrift. Sometimes it's ignored completely. It's always present, however. It's always there. There's no way to get around it. We can approach it by neglecting it, by not thinking about it, by giving it short shrift, etc. And we'll talk about some of those errors that we can fall victim to as we develop the logical architecture of our system designs. But this is a critical aspect of the system design and should not be neglected. To give us a basis for talking about this and for making the points that I want to make, and as I say, that what we're going to discuss is the larger picture with respect to the importance of the logical architecture. We're not going to go down into the logical architecture and say you should use this construct, or here's a trick that shows you how to map this behavior more successfully. We're going to talk about the larger picture of the importance of the logical architecture and the role that it plays. In order to do that, I thought we'd take a problem and an innovation that we all sort of know about, but we don't necessarily know about in detail. I know that as I did some research and looked into this for this presentation and several others that I've done, I've learned some very interesting things about this. But I want to take us to Europe in 1400. They have books, but book production is a very, very expensive and laborious process, which confines the books to the very, very wealthy, to wealthy institutions and a few very wealthy people, and therefore that confines literacy to a very, very few people. So you're not able to, if you could learn to read, there's not much point in learning to read because you're not going to have a lot of access to books and printed materials. The legacy system that is present at that particular point is the scriptorium. During the Dark Ages, the learning in Europe was basically preserved in the monasteries. Monks copied books. Books were written by hand. The original, and this is of course where we get our word manuscript, which literally means handwritten or handwriting. So these manuscripts were copied and kept in various forms. They were kept in scrolls. They were put on vellum or skins, put on early forms of paper, papyrus, and held together in what we called codices or a codex. But all of this had to be reproduced by hand. So the only way to get a copy of a book was to literally copy the book. And a number of monasteries across Europe had scriptoriums where monks sat and day after day they transcribed and copied from one manuscript into a fresh manuscript, creating a copy of the book. Of course, one of the very popular subjects of that copying was the Bible, and so it was copied and preserved. It took a single scribe working full-time about a year to produce a copy of the Bible by this method. So you can see that books would be very, very rare and hard to come by. Now, onto our stage, we're going to welcome Johannes Gutenberg. systems engineer. Gutenberg had done his early training as a goldsmith. His father had been in the metal trades, and Gutenberg apprenticed into that particular kind of a trade. Although we won't go into the details of his private life, he is a very interesting character, and if you want to research somebody and find an interesting story, he's an interesting guy. And if you're anyway disappointed by the non-racy aspect of what I put a racy title to here, you can make up for it by going and reading about Gutenberg. He was the subject of a breach of contract, failure to marry lawsuit, for instance. So, interesting guy. We're concerned about him because of his performance as what really is a systems engineer, probably in the highest, most creative sense of that word. So he becomes the character. And Gutenberg begins to think about this problem of reproducing books. Probably the most obvious idea that he stumbles over as a systems engineer is the same kind of idea that we stumble over very often. He had a legacy system. He was fully aware of how books were produced. So if one monk can produce one Bible in 1 year, if you want 50 Bibles, how about 50 monks? So the first idea that he would probably have thought about was the idea of additional monks. We'll simply make the scriptoriums larger, and we'll still copy by hand, but we'll copy more times by increasing the number of people who are toiling in that way. But fortunately for us and for the rest of the world, Gutenberg goes further than that in his thinking. His next step might be, and notice here that Gutenberg focuses on producing the books as opposed to focusing on how they're produced. He's open on how they're produced, but his purpose is, how are we going to produce more? How are we going to produce more of these documents? So had he chosen to go in this direction, he might have thought about how you leverage one monk's work. So how could a monk recopy a manuscript and at the same time have an additional copy made or additional copies made? Now, this idea might have led him to something like Thomas Jefferson, and this is a drawing of a machine like the machine invented by Thomas Jefferson, which copied over what you copied. Now, of course, Jefferson is later, and he invents this because he had difficulty getting the copier service people to come up on top of the mountain to Monticello to service his photocopier. So he had to have a way of making copies. And of course, I hope everybody knows that's a joke. The problem was that he wanted to keep copies of his correspondence without having to write the whole thing over again and introduce mistakes, etc. So he had this side writer, this 2-pen writer, and you could take hold of one of the pens and write with it, and the other pen would make exactly the same motions that you were making and would copy your writing. So Gutenberg could have gone down that avenue and said, okay, I have X number of monks, I can produce 2X number of copies, I can double the production now by following this. But he didn't, of course. We know exactly what he did. Gutenberg went to the idea of a printing press that could mechanically reproduce. Once you had set up the original, it could mechanically reproduce a number of copies, a large number of copies. And it wasn't that you could get twice as many copies as you had monks willing to work on it. It was that you could get many, many more. And this was his big invention. So the Gutenberg press was the innovation that Gutenberg introduces into the world. Now, this is going to become very important. it's arguable that the Reformation would not have had near the impact on Europe that it had it not been for Gutenberg's press as a way of reproducing the documents that were a part of the Reformation, a part of spreading the ideas of the Reformation. So when Luther posts his theses at the church in Wittenberg in 1521, the printing press is already well underway, and his ideas could be printed and distributed fairly widely, especially as compared to the days when handwriting was the only thing available. So this is very important. Now it's really interesting because Gutenberg's printing press is not a single advance. It's the synergy that comes from a number of advances. He makes advances in how it's done. He focuses on the behavior that he wants, the reproduction of many additional copies, and he draws on technology in a variety of ways from a variety of different fields. The first and most obvious as we look at his printing press is that it's a screw-type press. Now, Gutenberg would have gotten this idea from the agricultural industry. At this particular time, a screw press, where basically you capture the nut and the bolt, the very large bolt, screws down into the nut, and on the bottom of the bolt you put a plate that you use to mash or apply pressure with, and on the top you put a handle. And so as you tighten the handle, it goes down through the nut and presses down with the plate on whatever it is you want to press. So this became a good mechanism for pressing grapes, for instance, to get the juice, or other fruit, to get the juice from the fruit, which squirts out the sides and gets captured. He would have also seen these screw-type presses used in the dairy industry to squeeze the liquid out of cheese to get the drier cheese consistency. They would have used the screw-type press to do that pressing as well. So Gutenberg knows that if he is going to imprint the image on a piece of paper or whatever printing medium, vellum or skin or whatever he's going to print on, mostly paper for him by this point, he's going to have to apply pressure in order to get the ink to take on the paper. So he comes up with the idea of using the screw-type press, which can easily be pressurized by putting it on, and then you can take the pressure right off and pull the plate up when you're finished printing. So that's the big idea that's very obvious when we look at any drawing of his press. The next idea is that you need some way, something to load onto this pressurized plate that will make your image. At this particular time, they were using wood blocks, wood cuts, and they would take a chisel and cut an image into a block of wood, and then they would take the block of wood and ink it and mash it onto the paper, and the pressure would make the ink transfer to the paper and leave the image. This meant that you had to carve in relief. You had to have the areas that you wanted to appear in the image needed to be higher than the areas that around them that would show up as spaces. This had proven to be a real challenge for printing letters. For one thing, it's difficult to cut away and leave the raised letter on a block of wood if you try to do it at any size, at any small size. So if you're trying to get a very small letter and use a chisel as a way of leaving the letter raised on a small block of wood to print, say, a document or an article or a page out of a book, that was very, very difficult. The other thing was that it wasn't very durable. if you cut these things down, especially where you're cutting very thin letters, you had a problem because this thin area of wood sticking up gets mashed down by the pressure, and you're constantly having to renew that. So it takes time to produce it out of wood, and it doesn't last very long, so it's not really giving you a great advantage. Now keep in mind here that Gutenberg had a background in metallurgy. He had trained as a goldsmith. So he knew about casting metal. And he knew that he could make a mold, and if he took the mold and he pounded down the image of the letter in reverse into the mold, then or actually in the positive, he would pound it down into the mold, then he could pour molten metal into the mold, and the metal would run down into the area that he had depressed, the image area of the letter. And then when the molten metal hardened, he could pull the block with the letter on it up out of the mold. He could work with much smaller letters. He could produce a sharper edge than he could with wood, and he got something that was more durable. So what he wound up with were this piece of type, if you will, that contained a single letter on a block. And he could take letters on single blocks like this, and he could, by putting them into a frame, he could create a word with the movable type. That was a huge innovation. And that's probably the thing that Gutenberg gets the credit for most often, is the creation of the movable cast metal piece of type, which could be set and reset. It lasted longer than wood. It was easier to produce than wood. You could reuse the mold. So if a letter wore out or you needed more letters, you simply poured more molten metal into the mold and made more of these pieces of type. And so that was used, the movable type, and the typesetting became a part of his innovation here. The other thing is that he delved into the world of chemistry and was one of the very first to use a variety of oil-based inks, which produced a better quality image, and produced a longer lasting image. It was sharper. He was able to gain a number of advantages, using these oil-based inks. So that was an innovation. He worked on the inks. And finally, he worked directly on how this all took place. Rather than looking at one worker producing one copy of one document using this printing press, he realized very quickly that he could do a division of labor. And so he could have a typesetter and a pressman and somebody mixing the inks and applying the inks, and he could create a cooperative team that could perform the behavior that would take much longer if he had one or two guys at a time attempting to do all of the tasks. So he studied the behavior that it was going to take to operate the new innovations that he had, and put together a division of labor which gave him a significant advantage. The end result of that was that he produced a machine that could reproduce a large number of books. At first, most of the books were much bigger than the books we would think of today. The Gutenberg Bibles are substantially larger books. As he was able to refine his type making, he could set more lines of type on a given size of page, and that gave him some advantage. So he continued to innovate and to produce, but he had had unlocked the door to massive reproduction of printed materials that could be distributed much more cheaply. They became much more accessible. He could distribute them more widely, and they had a tremendous impact not only on his society but on our civilization all the way down through to today. Now let's look at some of the excuse me, behavior pitfalls. Some of the things that Gutenberg was largely able to avoid, and we'll talk about how he avoids this, but some of the pitfalls that we fall into as we begin to do innovative designs and to look at our systems and the functioning of the systems. The first one that I'd like to look at is just simply skipping behavior. I've had a number of people, and I came from the process world, so obviously I'll have prejudices about the importance of behavior. I have lots of vices in terms of things that I don't know or that I don't do well in terms of systems design, but underestimating the importance of behavior is not it, because I came from a world where the bulk of the system being designed was the behavior, the logical architecture. So it was surprising to me when I heard very experienced and highly placed engineers who said, I don't even need to fool with that behavior stuff. We would talk about systems engineering and the four domains, the requirements, the behavior, the physical architecture, and verification and validation. And they would say, I don't even need to, I don't need to represent behavior. I just simply take the requirements, figure out what component can perform that requirement. And what they actually mean there is perform the behavior that will satisfy that requirement. But they say, I just allocate requirements to components. And they skip it. Well, what does that do? If you skip that, what happens? Well, if you skip thinking about it, you constrain your choices, because we tend to think in terms of components that we already know. So how did we choose the components? We picked the components, and we'll talk about that in just a second. But you've constrained your opportunities to modify the behavior, to develop the behavior layer by layer, when you decide to skip the behavior and to simply allocate requirements directly to components. The other thing here is you really can't skip it. Just as the person who says, I pick a component that'll satisfy the requirement, no. You pick a component that will behave in a way that satisfies the requirement. So even if you're not thinking about behavior in an intentional way and you're not portraying it, it's there in the background, because it's the link between the requirements and the physical architecture. The physical architecture has value only insofar as it will aggregate to behaviors that will satisfy the requirements. So it's really there. You might not be exercising intentionality, and if you don't exercise intentionality, then you're constraining your choices and you're losing the opportunity to think about and modify and optimize the behavior. But you really can't skip it. In one form or another, it's there. It's just a question of whether you want to surface it and deal with it intentionally. The second kind of misbehavior is a focus on the physical. Some people call this component engineering. This results in constrained choices. I like to think of component engineering as something I engage in, even though I know better. This happens to be a photograph of a shelf in my cabinet. So often I will go to the shelf and I'll look at what's on the shelf and I'll say, what could I have for dinner? What can I fix for dinner? Well, Obviously, I could have something that's rice-based. I've got a couple bags of rice there, so I could fix that rice. I got a little bit of bread. I've got several different things that I could have. And so my architecture for supper is based upon what's in my pantry, what's in my cabinet. That's a focus on the physical. What that means is there's a whole lot of choices out there that might be more nutritious, that might be more interesting, more palatable, but they're not available to me because I'm constraining myself by looking at a subset of the possible components for my supper. So what are the consequences of this? Well, in terms of the logical architecture, if we think of behavior, especially at higher levels, we can make trial allocations of behavior to components. And we don't really allocate requirements to components. We allocate functions to components, or we allocate behavior to components. So we say, okay, I need the following behaviors. What components will perform those behaviors? And we can make trial allocations, and the trial allocations will suggest solutions. So had Gutenberg focused on the monks that were currently doing the writing, then he's got one choice that's right there that he's constrained with, and if he really thinks hard, he might have a second choice where the monk can copy, but it's not going to suggest the printing press to him at all. So he's going to miss out on that choice because he's constrained himself in this particular way. The third kind of misbehavior is what I call starting too low. We decompose behaviors as we begin the systems design, and we advocate a layered approach to doing a systems design and working things down in layers and decomposing each of the elements. Now, we advocate that we do this with requirements and behavior and the physical architecture and the verification and validation process, that we move from a very high level where Gutenberg might have described his system as a system that produces books. He might have a large black box of behavior. But by beginning at a higher level and then decomposing it as we move down, we're able to make that decomposition a framework for intentional choices. And we decompose our requirements as we go, and we look at the impact of how we're decomposing our behavior on the requirements, and certainly looking at the impact that it has on how we decompose the physical architecture. But we advance the system design layer by layer, picking up granularity as we go. Now, if we were to drop down quickly to a particular behavior, say we decided that we're going to drop down and we're going to say, all right, how can the monks copy the original text onto blank paper? How can they do that most efficiently? Then we might think of Jefferson's dual writing machine. But we're certainly at this point too far down in the behavioral hierarchy to ever think of the printing press. That's just simply not going to come onto our radar because we're so far down in that hierarchy. So what does starting too low cost us? It really costs us innovation. If you think of this as the innovation space, and that it seems to fade out into the background on the left side because we really begin innovation by thinking about the world. If you want to feed innovation, you have to feed your innovators information about the world and information about the cutting edge of thought and information about lots of different subjects, because there are three phases to the innovation cycle. an inspiration phase where we begin to come up with ideas, and then an ideation phase where we begin to frame those ideas, those inspired thoughts we frame into ideas and groups, and we begin to develop them. And then finally, as we look through the ideas that we've come up with, we're narrowing the scope, and we get down to the point where we try to validate it. We think, this may work. Let's test that. We can imagine Gutenberg doing that. You know, perhaps he took a wooden block at some point and attached it to the bottom of a screw press and put a piece of paper underneath on a table and screwed the press down to the point where it pressed the wooden block with the image on it, and then pulled it back up to see what kind of an image it has. That's a validation stage that you would move into as you begin to narrow your ideas. But what happens if we start too low? If we start down at the stage where we've defined lots of things, we cut out the inspiration stage and much of the ideation stage, because we're allowing the very granular behavior ideas, the very granular logical architecture where we're thinking, to cut off the ideas that would come from the left there, from the earlier stages of the innovation cycle. So we truncate our innovation, and we can move only toward validating those ideas that enter at that particular point, and we've lost our opportunity for true innovation. The next misbehavior is failing to complete the behavior. Whereas we were talking before about not going high enough into the behavior architecture, very often it's tempting to kind of get the logical architecture sort of fleshed out and then move over into the physical and not worry so much about the behavior anymore. We literally will fail to complete that architecture, and we have a tendency to not define or to leave out steps, to not think about particular aspects of the logical architecture, and leave out actors. Fail to consider what the actors will produce. One of the most common manifestations of this is doing systems designs where they don't think about human behaviors. I worked in an organization that their principal business was writing reports, much like a financial house, for instance. The analysts will write reports about stocks or companies or whatever. So they took a lot of information and distilled it down and wrote reports. And as they wrote, say, these financial reports, they had learned that they were dealing with a system where there was so much demand on the servers that the servers were kind of glitchy and they had a tendency to go down. So they learned to, at the end of every paragraph, press Control-S, because that saves your work. And so if you had a server go down, you never lost more than one paragraph's worth of work, because you're hitting Control-S and saving regularly. Well, they have asked for a new piece of software for their report writing that would include lots of bells and whistles and some ability to bring things in, etc. And they got this brand new piece of software, and it was great. It did the kinds of things that they hoped it would do. It provided them with the opportunity to incorporate different tools into their workflow, and it was great. But they discovered, as they wrote reports in it, as they got to the end of a paragraph and hit Control-S, it took a 60 to 90-second timeout while it did the saving. So the saving operation started to introduce a delay into it. So if you're writing a 10 or 12 page report, and you're hitting Control S at the end of every paragraph, how much time is wasted while you wait out this cycle? What happened was that people were discouraged from hitting Control S. I'll just take the risk rather than have the delay. I can't afford the delay. So I'll write without the Control S being pushed. Well, that went along, and it wasn't optimal, but it was okay, and they operated in that particular way until they discovered another previously undocumented feature of the new software. And that was, if you hit the undo button, it did not just undo the last thing you did. It undid everything you had done all the way back to the last time you had saved. So what they had done was they had introduced a system where the system discouraged regular saving of the document, and then if you hit the undo button, it would go all the way back. So it would go all the way back to the beginning of your document, perhaps, and wipe out what you had done. All of this by way of saying that the real culprit here is that they had failed to think about the actual behavior of the human operators. You have folks who design systems who fail to think of the human operator as even a part of the system, much less to think about the behaviors that the human operator will introduce into your logical architecture. So the result of leaving out actors and particular behaviors is that you get poor performance. You have performance issues. The system doesn't do well. It introduces problems, even problems that not only were unanticipated, but problems that had never been seen before. So we have to be careful to do that. Now, one of the very best things that Gutenberg did, and some authors argue that this is the biggest innovation that Gutenberg introduced. Gutenberg went to a division of labor. Gutenberg looked at the behavior involved in printing documents using this new mechanism and began to see that there were different roles that could be performed and that you could operate it more efficiently if you performed these roles by dividing up the labor and giving people specific roles within the overall behavior. So you have a pressman who operates the press, takes the rack of type that's been set and puts it into the press, attaches it to the bottom of the lever. It's already been inked, it's ready to go, and then the press operator, the pressman, simply presses it onto the paper, creates the image, releases the paper, and puts a new piece of paper in, and every so often re-inks the type that's been set. And when you change documents, you get another set of type that has been set up by the typesetter. And the typesetter simply takes those chunks of movable type that we talked about and learns to set those. It's a very interesting process. When I was a small child, I had a great uncle who published a newspaper, and they set the type by hand. And we thought it was fascinating when we visited them in the summer to go down to the newspaper, and he would let us set type. Our mom was not particularly appreciative of that, because you can imagine what three boys who have been setting inky type come away looking like. So she was always careful to ride the borderline of clothes that were socially acceptable and clothes that could stand getting dirty on the adventures he took us on. But it was a skill. You know, you have to set it backwards and everything has to be in position. Gutenberg also incidentally pioneered making marks on the non-printing part of the type so that those marks could be aligned and you could scan the type and quickly see if something was set out of line or set at a 90-degree angle. So you had the typesetter who did that, and then you had the inker who mixed the inks, and Gutenberg was using oil-based inks, which was a new innovation. And the inker prepared the inks and then applied those to the plates and made sure that there was enough and that the ink was of quality, and that part of the operation was running smoothly. So this was a big innovation on Gutenberg's part. It was one of the very first division of labor examples that we have. So what was the secret of Gutenberg's success, and what does it have to say for us? The first thing is he succeeded because he began his thinking at a high enough level to see the landscape of the potential solutions. He thought about this process in terms of what he needed to produce. And he thought about how he was going to do it in those terms. He began at a high enough level. Very often we don't want to begin at the high level. We want to begin too low, and so we miss seeing the possibility. Gutenberg saw those possibilities, and he saw possibilities in related areas. He had training in the metallurgical skills. He knew about casting metal. So he knew that he could cast that type, that he could produce raised type efficiently, and he could do it in a way that could be done over and over. He avoided a particular casting method for a number of reasons, which was sand casting. A lot of times you made a model of what you wanted and then pressed it into sand and then poured the metal into the sand, but that wasn't durable enough. And Gutenberg came up with a metal trough that produced metal ingots of a particular size with the image on one side of them. So he was able to produce that type in quantity and quickly enough. But he got all of that from his knowledge in an unrelated area, in the area of coin casting and goldsmithing. His press comes from the agricultural presses. Who would think of using the press that presses the liquid out of cheeses as a way of applying the pressure for paper? Now, we all would today. We all instantly see that relationship. But we see that relationship because Gutenberg told us it was there. And then he was able to, as he developed his architecture and developed his behaviors and recognized what the technologies were and how they would impact it, he was able to refine the technologies. So he was able to use the behaviors that he wanted. He wanted this image to be pressed down onto the paper, and he wanted to be able to print type that was small enough that he could get. And one of his innovations was the 42-line Bible, where he got 42 lines on a page, where previously there'd only been the ability to get 40. And that was a huge achievement because, as everybody who's ever done proposals knows, if you can put more lines on one page, it's easier to meet the page limits. For Gutenberg, it was the size limit for the finished product. How big is this Bible going to be? How much is it going to weigh? And so he was able to look beyond the wood blocks that were existing technologies and ask himself about how to produce the behavior that he wanted. And then finally, he studied the behavior itself. He specifically looked at the behavior itself, and rather than simply lumping all of the human functions for this printing press onto the back of a printer, or a printer and a helper even, he did a division of labor, a specialization that if it had not never been done before, it had not been done very frequently before. So it was a big innovation on his part. But he only came to that by studying the behavior. So Gutenberg's accomplishment is huge. The French mathematician Poincaré said, to create consists of making new combinations. The most fertile will often be those formed of elements drawn from domains which are far apart. If we want to be innovative, we typically make new creations. A lot of stuff in Gutenberg's innovation is not new. The combination is new. But if we can't think in terms of the system behaviors and begin at a sufficient altitude, then we're not going to be able to see far enough to see into domains that are far apart. So that's the genius of this, is that we need to develop our behavior from the top down, and we need to do it in concert with the development of the rest of the system, and we need to be able to see far enough apart to make true innovations. So that's our major point with respect to behavior. And if you noticed, all of the different misbehaviors, all of the ways that we as engineers behave badly, had to do with prematurely costing ourselves the altitude, the view, the landscape, by going too low too fast, or by giving short shrift or ignoring the logical architecture. So now, if you have questions, I am more than happy to take them.
All right, well, thank you, Zane. That was very interesting. I want to invite our audience to join the discussion now and submit questions using your chat feature. Moving on to questions, we have one from Eric. How do you protect yourself from moving too quickly to defining behavior in too much detail?
Eric, that protection is really built into visualizing the development of your design as a layered process, intentionally beginning high enough and then intentionally moving down layer by layer and resisting the temptation to go deeply. So the old temptation to develop everything all the way down as far as you can possibly develop it as quickly as you can come back to bite you in the end. So I would have to say that it's the layered approach. And more than the layered approach as a process, but the layered approach in the way you think about design is your best protection from that.
All right, thank you. We have another question from Keith. How does one deal with a company and management structure that presupposes an architecture prior to the start of a program, thus eliminating the need to do a system design and therefore focusing us to start too low in the view?
Well, I guess in one sense that the marketplace will deal with it. Because if you fail to innovate, then you get left behind. And if you engage in that kind of a practice, then you'll fail to innovate. So it's advocating this approach, and that can be tricky. Advocating it within your space and to the extent that you can, even with pieces of the design to improve the design. But ultimately, I guess it would be argued by the free market theorists that the market will take care of this, because these will not be organizations that will learn and innovate.
All right, next question is from Kirk. Actually, before I get to his question, let me go ahead and read to you Keith's follow-up question. He says, thank you for the answer. It is pretty much what I have experienced in a few cases. Okay. So next up we have our question from Kirk. How would you define the difference between a functional and logical architecture, or are they really one and the same?
I think the answer to that is B, that they're really pretty much one and the same, at least in my thinking.
All right, thank you very much. That is all the questions that I've received so far. So if you have any more questions, go ahead and type them in now. I'm going to wait just a few more seconds. And it looks like we're not really getting anything else. So, yep, looks like that is it. Okay. Well, thank you, Zane, for the Q&A. That wraps us up. And if anyone thinks of any other questions or comments that you didn't get a chance to send in, we invite you to post them on the forum or community site at community.vitechcorp.com. And I will chat that out to you now. There you go. Actually, we do have one more question from Kirk. How about reverse engineering up? Is it really possible to innovate that way?
Yeah, it's definitely possible. And that's an exciting particular way, whether you're engineering up from an existing system in a kind of a middle-out approach, or you're doing true reverse engineering and working back, because what you're doing is you are engineering back to the higher levels. So you want to get yourself back to the point where you're asking the question, you know, what are the needs for the system, and what are the behaviors that will satisfy those needs. So what you do is you reverse and you back yourself up to the high level question, and then you kind of come down the other side. So it's really an inversion that starts you back into the innovation process. But there are exciting possibilities there, because you are allowing yourself to go as high as you need to go in order to make innovations.
Looks like we have a few stragglers here who are just formulating their questions. I have a few more for you. I have one from Michael. What do you think about the recent subconcept paper?
I'm not sure that I'm familiar with that.
All right, Michael, if you could clarify for us. I'll move on to the next question. This one is from David. Comment when mapping functions to physical architecture, the logical architecture captures functions, interfaces between functions, and internal I/O, allows one to see the complexity of interfaces between physical elements and guide trays between physical element complexity versus interface complexity. Do you want me to read that one again, Zane?
I think that's a comment rather than a question, and I think it's a very well taken comment. It expresses it very well, and I think any of that that you learn gives you insight that you can use in your design. The key there is that you are doing that mapping, that you are seeing those connections.
All right, thank you. I have a clarification here from Michael about the paper. He says it's by Sandy Friedenthal, shows using logical stereotypes and operations to do the architecting. It's in the OMG SysML wiki site.
I haven't read that at this point, so I wouldn't want to comment except to say that the answer, I haven't read that, won't be true at midnight tonight.
All right. Okay, moving on to our next question from Mark. How do you sell system engineering and the steps entailed, such as the functional and logical breakdown? If project managers don't believe that functional decomposition is not needed, how would you sell this?
I think what you have to do, and it's tough. I mean, that's one of the toughest things that we come across is getting folks who don't get it to see it. And I think it's a matter of showing them where the potential gains are in terms of innovation, in terms of delivering a more effective solution, in terms of having a more comprehensive approach. All of those things are are benefits, and really what you have to do is sell the benefits. That's the only thing that's going to interest folks. You can almost never sell the approach. You have to sell the benefits of it. And I feel for you. I fight that battle regularly as we try to sell this approach in the general marketplace.
Okay, we have a question up from Richard. He says, we're calling this systems engineering. To what degree does it apply to business analysts?
Well, here's a news flash. As a business analyst, process analyst, you really are systems engineers. Those folks are building systems. The issue becomes, and this is another battle. Folks who think of themselves as engineers, because of the way that we handle that at a society or civilization level, engineers build things out of things. And business analysts look at business enterprise practices. And so I came to systems engineering without knowing that I was coming to systems engineering. The common thread is the systems thinking. Jim Long used to fuss with me. I would say I'm not an engineer. I'm not a systems engineer. I don't have an engineering degree, and Jim would always fuss with me over that, and he would say the key here for a systems engineer is the word systems. Don't emphasize the engineer word, emphasize the systems word, because immediately when you begin to talk about engineering, you begin to talk about things. But a business analyst is someone who is every bit as much of a systems engineer as somebody who calls themselves a systems engineer. It's just that the interfaces are different, the components are different. Very often the components are humans. They interface in different ways, so it's not a hardware or software intensive, but a people intensive, a people process intensive. So you can use the principles of systems engineering and let them fully apply in the business world. Now, I don't suggest that you go to business managers and say, hey, I'm here to systems engineer your processes, because they won't resonate with that language. But what they're doing and the role they're performing is systems engineering and systems engineer.
All right, thank you, Zane. A few more questions here. This one is from Kirk. In your experience, how do you determine what architectural element and level to allocate requirements that are at first conceptual in nature and therefore abstract, but increase over time in fidelity and should allocate to lower level architecture elements?
I think what you're pointing out is well taken, and you begin with I don't want to say looser, because there is a definite allocation at the higher levels, but you begin making allocations that are exactly as you've pointed out. They're more general in nature. They're less well developed. And what you're looking for is sufficient granularity in your logical architecture to respond to the granularity in your requirements, and a sufficient granularity in your physical architecture to respond to the granularity in your logical architecture. So what you're doing is you're balancing these back and forth, and you're working at any given level back and forth among the domains. And don't forget verification and validation, because that needs to come along and to become more granular. Now, at some point, those things may be undefined. You should validate your high-level requirements, for instance, but verification is going to be pretty sketchy until you get down to where you can actually engage in verification, testing, and evaluation. But your granularity needs to be sufficient to match the level across the domains, and you need to advance all the domains to each successive layer.
All right, well, looks like we're running out of time, Zane. I want to thank you all very much for such a vibrant Q&A. And as I mentioned earlier, if you have any more questions, you can start a chat at community.vitechcorp.com. And a recording of today's webinar will be posted in our resources section of our website within the next 24 hours. I'd like to thank you all for joining us, and be on the lookout for our next webinar. We will be adding it to the calendar hopefully in the next few days. And let me chat out the link to the webinar calendar in case you don't know where that is. So at the conclusion, go ahead, Zane.
Oh, while you're doing that, let me say thank you for your time and attendance, and thank you for the Q&A. That was fun, and especially thank you for the reference to the resources. I love that, and it helps me to broaden my thinking. So I welcome that. And if you know of other resources that you think I ought to know about, or you'd like my comment on, my email is up there as well. So send them along.
Yeah, if I know you, Zane, I know you're going to go and read it tonight, if not sooner. So.
Yeah, if my screen wasn't up, I probably would have already been looking for it.
Right. All right. So at the conclusion of the webinar, you will see a survey open on your screen. Please take a moment to give us feedback on today's presentation or any topics you'd like to see covered in future webinars. So that is all for today. Once again, thank you very much for joining us, and have a wonderful day.